Good afternoon, sir. I am Preeti from Section B. My roll number is 620239. Here I am going to explain my topic, that is a Fibonacci method using optimization techniques, as this is the introduction. Yes, and why we use this Fibonacci method means, yes, we have to find the minimum or maximum solution of a function. Fibonacci method, it is similar to the golden search method also. Yes, we have to find the minimal or maximum of a unimodal function between the interval like a to b. And function should be unimodal. Unimodal means that is monotonically increases or decreases for a certain interval. And we have the function, what's it? We have the, yes, it is the formula of the function fn equal to fn minus 1 minus 2, where n is greater than 1, where this is a Fibonacci series. Yes, we know or all know that the Fibonacci series is 0, double, 1, 2, 3, 5, 8, 1, 3, 2, 1, and this is the Fibonacci series. How we get this number 2 or resultant 2? We are adding the two preceding numbers. So we are getting this number, that is Fn equal, this is a formula, and this is the example of Fibonacci series, where a number of branches in a tree follows the Fibonacci series, and this is the number of petals in a sunflower, that is also follows the Fibonacci series. And here I am explaining the algorithm, finding the optimal solution. Yes, this is a given interval of the solution for uncertainty that L not equal to A comma B, and N is the number of experiments or iterations we have to do in this problem. And to find the values, that is x1, x2, with respect to function values, we have to find for the solution, to find the optimal solution of the given function using MATLAB here. Here determine the x1 values, x2 values. How we can determine? Yes, to find the x1 value, x1 equal to a plus L2 star. To find the length of the interval, that is L not equal to a comma b. To find the L not, that is the length means b minus a, we have to do. And then to find the x1 values, x2 values, x1 equal to a plus L2 star, x2 equal to b minus L2 star. These are the values. And then we go with the L2. Yes, we have the initial value, that is L naught, that is L naught. How we can find means b minus a, that is the length of the interval. And after we have to find the x1 value, x2 value, and then we are with respect to x1, x2, we are finding the function values. And then from that, if f of x1 is greater than f of x2, we have to discard the f of x1. Like that, we have to find the x1 values, f of x2 values, f of x1 values, and then initial and new length values. Here, this is a example, f of x equal to x square plus 2x with interval, that is minus 3 comma 4, that is a comma b, using Fibonacci method, using optimal value, that is with respect to 5% exact value. This is the accuracy. So this is the Fibonacci series, 0, 1, 1, 2, 3. Yes, this is the function value. To find the number of iteration, how to find means, from this they are giving the 5% accuracy value. From that we are finding the number of iterations take part in this problem. To find the length, minus 3 comma 4, that is b minus a, that is 7. And then we are going to find the f of x1, x2. We are finding the x1 value. This is the x1 equal to a plus L2 star, where we are finding the L2 star, that is the length. And x1, how we can find x1 means a plus L2 star. Here we all know that a equal to minus 3. To find L2 star, this is the fn minus 2 by fn into L naught. We are all know that L naught equal to length of the, what's that, interval, that is b minus a. So in that way we are finding x1, x2, and then with respect to function values, f of x1, f of x2. Here f of x2 is greater than f of x1. So we have to discard the f of x2, and then our new interval with respect to starting with f of x1. So like that, we are discarded x2b. Okay, and then step 3, we are finding the new length, and then x2 value we are finding with respect to function value f of x1, f of x2. Here f of x1 is greater than f of x3, so we have to discard it x1. So like that we are finding f of x4, f of x5. So similarly, f of x y, f of x y, and this is my code using MATLAB, and this is the conclusion of the Fibonacci method. This is yes, this is a effective method for finding the maximum or minimum value using using Fibonacci method, and it is a useful tool in a optimization toolbox. So like that, I find the Fibonacci method using MATLAB. Here I am explaining code. This is a function, my function f of x equal to f of x square plus 2x. And this is a function, and then yes, a, b, our intervals like a equal to minus a, b equal to. From this, I am going to explain a graph. This is my report. And this is the examples, and here I'm taking the example like a same in the ppt x square plus 2x. From this I'm finding the optimal solution, and this is the algorithm. Define the function using MATLAB. Find the root of the case. We are finding the f of x1, f of x2, like that. And define the interval. Yes, root. Set the initial values. Here we are all know that a b. They are giving the a comma b. That is the interval of the function. Low a means lower interval, and b is the upper interval, and number of iterations takes part in the problem in the Fibonacci process. And then we are finding the number of iteration. From there giving the accuracy value. From that we are all find the what's that number of iteration takes parts in the problem. We are finding the f0 f1 with respect to x1 x2 x1 equal to a plus b minus a into f naught by fn, that is nothing but length, initial length by final length. So with respect to x1, x2, we are finding the functions with respect to f of x1, f of x2. If f of x1 is greater than f of x2, we can discard the f of x1. So like that, we can find up to the number of iterations, that is 6 iterations we are taking. And this is the initial values of Fibonacci f of 0, 0, f of 1, f of 2 equal to also 1. So calculate x1, x2 with respect to function values. So this is here I am taking 2, 3 function values, and then I am finding the output of the functions. So this is a graph model. So this is a way in the XY plot. This is this is my code and explanation, and this is the conclusion from Fibonacci method. Uh, to have in a optimization tech toolbox, and MATLAB provides a convenient platform for implementing the experiment in this technique. Thank you.